Hello everyone, today we're going to talk about element number 85, astatine. So astatine, radioactive chemical element and the heaviest number of the halogen elements, or group 17 of the periodic table. Astatine, which has no stable isotopes, was first synthetically produced in 1940 at the University of California, seen here. The University of California was first founded on March 23rd, 1868. Here's the University of California in the map, 1940, when astatine was created. So it was first synthetically produced in the University of California in 1940 by Dale R. Corson, Kenneth R. Mckenzie, and Emilio Sergi. Emilio Gino Sergi was an Italian-American physicist and Nobel laureate who discovered the elements technetium and astatine and the antiproton, a subatomic antiparticle, for which he was awarded the Nobel Prize in Physics in 1959, along with Owen Chamberlain, according to Wikipedia. He was born January 30th, 1905, in Tivoli, Italy. He died April 22nd, 1889, in California. Here we have Kenneth Ross Mckenzie. Kenneth Ross Mckenzie, together with Dale R. Corson and Emilio Sergi, synthesized the element astatine in 1940. Mckenzie received a PhD at Lawrence Livermore National Laboratory. Lawrence Mckenzie and their colleagues devised the first cyclotron, according to Wikipedia. Kenneth Ross Mckenzie was born June 14, 1912, in Portland, Oregon. He died July 4, 2002, in Los Angeles, California. His education was at the University of California, Berkeley, and the University of British Columbia. Dale Raymond Corson was the 8th president of Cornell University. Born in Pittsburgh, Kansas in 1914, Corson received a BA degree from the College of Emporia in 1934, his MA degree from the University of Kansas in 1935, and his PhD in physics from the University of California, Berkeley in 1938, according to Wikipedia. He was born April 5, 1914 in Pittsburgh, Kansas. He died March 31st in 2012 in New York. Astatine is a chemical element with the symbol At and atomic number 85. It is the rarest naturally occurring element in Earth's crust, occurring only as a decay product of various heavier elements. All of astate's isotopes are short-lived. The most stable is astatine 210 with a half-life of 8.1 hours according to Wikipedia. Its symbol is At, its atomic number is 85, its electron configuration is xenon, 4f14, 5d10, 6s2, 6p5. Its atomic mass is 210 U. Its melting point is 575.6 degrees Fahrenheit or 302 degrees Celsius. It was discovered in 1940. Its boiling point is 638.3 degrees Fahrenheit or 336.8 degrees Celsius. Again, it's radioactive. Be cautious and mindful of radioactive elements. So these individuals bombarded bismuth with accelerated alpha particles, helium nuclei, to yield astatine 211 and neutrons. So an alpha particle is a helium nucleus without its electrons. So they bombarded bismuth. Bismuth is element 83. It's used to make Pepto-Bismol. And here we have bismuth being bombarded with helium nuclei to form astatine 211 and neutrons. Naturally occurring astatine isotopes have subsequently been found in minute amounts in the 3 natural radioactive decay series, in which they occur by minor branching: astatine 218 in the uranium series, astatine 216 in the thorium series, and astatine 215 and astatine 219 in the actinium series. 32 isotopes are known. Astatine 210 with a half-life of 8.1 hours is the longest lived isotope, as previously mentioned. Because astatine has no stable or long-lived isotopes, it was given its name from the Greek word for astatos, meaning unstable. So the only practical way of obtaining astatine is by synthesizing it through nuclear reactions. Astatine is usually prepared according to the general equation, seen here, which indicates that bismuth 210 takes up 1 alpha particle, or helium without its electrons, and emits X number of neutrons to form an isotope of astatine, whose atomic weight depends on the number of neutrons lost. Metallic bismuth may be used as a target material. From this, astatine may readily be removed by distillation in air from stainless steel tube. The free element begins to distill at 271 degrees Celsius or 520 degrees Fahrenheit, or the melting point of bismuth. But the operation is best carried out at 800 degrees Celsius or 1500 degrees Fahrenheit with subsequent redistillation. If an aqueous solution of astatine is desired, the element may be separated by washing with an appropriate aqueous solution. Alternatively, the halogen may be removed from the target by chemical methods such as dissolving in nitric acid, with the latter being removed by boiling. Another procedure involves the use of a metallic thorium target, which after bombardment is dissolved in concentrated hydrochloric acid containing hydrogen fluoride and chlorine. Thorium is element number 90. Here we have hydrochloric acid, hydrogen fluoride, and nitric acid. Handle with care. So because of the short half-lives of astatine isotopes, only very small quantities have been available for study. Have used tracer techniques which involve using chemical reactions in a solution with similarly reacting elements as carriers. With the exception of a few spectrometric and mass spectrometric studies, most investigations of astatine chemistry have used tracer techniques which involve using chemical reactions in a solution with similarly reacting elements as carriers. The amount of astatine is then calculated from the measured radioactivity of the reaction products. However, the rarity of astatine means that that these solutions are extremely dilute with concentrations around 10 to the power of negative 10 molarity, the number of moles per liter of solution. At such concentrations, the effects of impurities can be very serious, especially for a halogen such as astatine, which exists in several oxidation states and can form many organic compounds. Iodine has been used as a carrier in most experiments. Techniques applied include coprecipitation, solvent extraction, ion exchange, and other forms of chromatography, separation by absorption differences, electrodeposition, deposition by an electric current, and electromigration, movement in an electric field, and diffusion. A direct identification of some astatine compounds has been made by mass spectrometry. Here we have mass spectrometry. Mass spectrometry is essentially a way to measure the different types of elements or various compounds present by accelerating them and analyzing the differences in acceleration to determine the differences in isotopes or elements. As seen here, zirconium, 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 zirconium. The differences in the isotopes accelerated differently, and so they were detected differently by the spectrometer. Except for nuclear properties, the only physical property of astatine to be measured directly is the spectrum of atomic astatine. Other physical properties have been predicted from theory and by extrapolation from the properties of other elements. So some of the chemical properties of the element have been established. It generally resembles iodine. It's in the same group. Here we have fluorine, chlorine, bromine, iodine, and astatine. This is a beautiful fluorescent uranium mineral called autunite. It consists of the elements calcium, uranium, oxygen, phosphorus, and hydrogen. Here we have astatine, element number 85, calcium, element number 20, uranium, element number 92, phosphorus, element number 15, hydrogen, element number 1, and oxygen. Thus, like iodine, it concentrates in the thyroid gland of higher animals. A substantial portion, however, is distributed throughout the body and acts as an internal radiation source. So the astatine ion, At, is quantitatively coprecipitated with insoluble iodides such as silver iodide or thallium iodide. The diffusion coefficient of the iodide ion is 1.42 times that of the astatine ion, which moves more slowly toward the anode than the former under given conditions. The ion is formed by reduction of the element using zinc or sulfur dioxide. It is oxidized to the zero valence state by the ferric ion Fe3, iodine I2, and dilute nitric acid. Thus, the astatine ion is a stronger reducing agent than the iodide ion, and the free iodine is a stronger oxidizing agent than astatine. So free astatine is characterized by volatility from solution and by extractability into organic solvents. It undergoes disproportionation in alkaline media. Astatine is co-precipitated with cesium iodide and thus appears to form polyhalide anions. Astatine extracted into chloroform has been shown to copreciate homogeneously with iodine when a portion of the latter is crystallized. Astatine seems to be present as the iodide, which appears to be more polar, i.e. showing separation of electric charge, in character than iodine bromide. It is somewhat soluble in water and much more soluble in benzene and carbon tetrachloride. So here we have carbon tetrachloride. It's a chemical compound. Carbon tetrachloride, also known by many other names, is an organic compound with the chemical formula CCl4. It is a colorless liquid with a sweet smell that can be detected at low levels. It is practically not flammable at lower temperatures, according to Wikipedia. Its formula is CCl4. Its IUPAC ID is tetrachloromethane. Its molar mass is 153.82 grams per mole. Its boiling point is 170.1 degrees Fahrenheit or 76.72 degrees Celsius. Its melting point is negative 9.256 degrees Fahrenheit or negative 22.92 degrees Celsius. Its number of valence electrons is 32 according to infoplease.com. It's soluble in chloroform, benzene, and carbon disulfide, and alcohol. It consists of one carbon combined to 4 chlorine atoms. And here we have benzene. Benzene is an organic chemical compound with the molecular formula C6H6. The benzene molecule is composed of 6 carbon atoms joined in a planar ring with 1 hydrogen atom attached to each. Because it contains only carbon and hydrogen atoms, benzene is classified as a hydrocarbon. It's now known to be carcinogenic. Its molar mass is 78.11 grams per mole. Its formula is C6H6. Its boiling point is 176.2 degrees Fahrenheit or 80.1 degrees Celsius. Its IUPAC ID is benzene. Its density is 876 kilograms per meters cubed. Its freezing point is 5.48 degrees Celsius, according to purdue.edu. It's soluble in alcohol, acetic acid, and acetone. Again, when handling these products, handle with care and be mindful of others. Its symbol is At, its atomic number is 85, its atomic weight is 209.99, its color is unknown, its standard state is solid at 25 degrees Celsius or 77 degrees Fahrenheit. Its classification is non-metallic. Sorry, I must rush. I've just got to pop. You see, I'm super radioactive and I don't hang around if I can help it. I have a half-life of just 8 hours. I'm a rarer than rare element. No sooner have I formed by the radioactive decay of a heavier element than I break down. They even gave me a name that means unstable. Well, fancy that. Its density is 6.4 grams per centimeters cubed. Its melting point is 302 degrees Celsius or 576 degrees Fahrenheit. Its boiling point is 230 degrees Celsius or 446 degrees Fahrenheit. Here you have some more information on astatine. So only tiny amounts of this radioactive halogen exist in nature. Around 1.05 ounces or 30 grams in all of Earth's rocks put together. Astatine atoms are formed when francium and polonium atoms decay. Its atomic mass is 210. Its state is solid. Its discovery was in 1940 by Dale R. Corson, Kenneth Mckenzie, and Emilio Sergi. Uranite, an ore of uranium, contains a very small amount of astatine. So astatine is known to occur in positive oxidation numbers. The acetate ion, AtO3 negative, is co-precipitated with insoluble iodates such as silver iodate, AgIO3, and is obtained by the oxidation of lower oxidation states with hypochlorite, periodate, or persulfate. So far, no evidence for perestate has been found. This may be because the ion AtO6 5 negative may show little tendency to co-precipitate with potassium iodate, or KiO4. Astatine in the +1 state is stabilized by completion and complexes formulated by dipyrene astatine perchlorate, or ATPY2Cl O4 and dipyrene astatine nitrate ATPY2NO3 have been prepared. Compounds with the formulas C6H5AtCl2, C6H52, and ATCl and C6H5ATO2 have also been obtained. A variety of methods may be used to synthesize astatobenzene, or 6 atoms of carbon, 5 atoms of hydrogen, and 1 atom of astatine. So that was astatine explained in 25 minutes or less. If you like this video, make sure to like, comment, subscribe. Other than that, thank you everyone for watching. Have a great one.